Assalamualaikum warahmatullahi wabarakatuh. I'm Rika Pratiwi, the 6th semester of English Education in the Global Mandiri University. I would like to explain about summary chapter 11, 12, 13, and 14 of educational research books that written by John Creswell. Okay, without any further ado, let's get to the list. In this video, I would like to explain the summary of chapter 11 that talking about correlational design. So this is 5 points that we will talking in this chapter. What is correlation research design? Correlation research design provides an opportunity for you to predict scores and explain the relationship between variables that using the correlation statistical test to describe and measure the degree of association or relationship between two or more variables or sets of scores. For the example, prediction that ability, quality of schooling, students' motivation, and academic coursework influence students' achievement. Anderson and Kate, 1977. What is correlation? Correlation is a statistical test to determine the tendency of pattern for two or more variables or two sets of data to vary consistently. In the case of only two variables, this means that two variables share common variance or they co-vary together. Co-vary itself can predict a score on one variable with knowledge about the individual scores or on another variable. Product moment correlation coefficient is the statistic that expresses a correlation statistic as a linear relationship, also called bivariate correlation. Kettner, Smith, and Parnell, 1977, said that we can use correlation design when we seek to relate two or more variables to see if they influence each other, such as relationship between teachers who endorse developmentally appropriate practices and their use of the whole language approach to reading instruction. We also use the correlation design when we know and can apply statistical knowledge based on calculating the correlation statistical test. So, this is the types of correlational design. The first one is explanatory design. Explanatory design is correlational design in which the researcher is interested in the extent to which two variables or more co-vary, that is, where changes in one variable are reflected in changes in the other that consist of a simple association between two variables or more than two variables. The example of two variables is sense of humor and performance in drama. And the example of more than two variables is pressure from friends or feeling of isolation that contribute the being drinking. And this is the characteristic of explanatory design. The investigator correlate two or more variables. The researchers collect data at one point in time. The investigators analyze all participants as a single group. The researchers obtains at least two scores for each individual in the group. The researchers reports the use of the correlation statistical test, and the researchers the interpretation or conclusions from the statistical test result. The second type of correlational design is the prediction design. Prediction design is a variable used to make a forecast about an outcome in correlational research. In the case of predicting teacher success in a school, the predictor may be mentoring during teacher training or year of experience teaching. The purpose of a prediction research design is to identify variables that will predict an outcome or criterion. In this form of research, the investigator identify one or more predictor variable and a criterion or outcome variable, the outcome called criterion variable. And this is the characteristic of prediction design. The authors typically include the words prediction in the title. The researchers typically measure the predictor variables at one point in time and the criterion variable at a later point in time. The authors forecast future performance. Okay, next about the characteristic of correlational design. The first characteristic of correlational design is display of score. Scatter plots is a pictorial image display on a graph of two sets of scores for participants. These scores are typically identified as X and Y, with X values represented on the horizontal axis and Y values represented on the vertical axis. A single point indicates where the X and Y scores intersect for one individual. This plot can provide useful information about the form of the association, whether the scores are linear or curvilinear. It also indicates the direction of the association and the degree of the association, whether the relationship is perfect with a correlation of 1 or less than perfect. And this is the example of the scatter plots. In this table, hypothetical scores for 10 students are collected and plotted on the graph. Several aspects about this graph will help us for understand it. The hours of internet use variable is plotted on the x-axis, the horizontal axis. The depression variable is plotted on the y-axis, the vertical axis. Each student in the study has two scores, one for hours per week of internet use and one for depression. A point of the graph indicates the score for each individual on depression and hours of internet use each week. And there are 10 scores points on the graph, one for each participant in the study. Okay, and this is the types of display of score. That is correlation matrix. Correlation matrix present a visual display of the correlation coefficient for all variables in a study. This display, we will list all the variables on both a horizontal row and a vertical column in the table. Next, about the association between scores. The direction of the association is positive correlation and negative correlation. Positive correlation, the point move in the same direction. That is, when X increases, so does Y, or alternatively, if X decreases, so does Y. Negative correlation is the points move in the opposite direction. That is, when x increases, y decreases, and when x decreases, y increases. If scores on one variable do not relate in any pattern of the other variable, then no linear association exists. The form of the association, there are linear relationship and uncorrelated and nonlinear relationship. In linear relationship, there are positive linear correlationship and negative linear correlationship. The uncorrelated and nonlinear relationship, we have uncorrelated relationship and nonlinear relation. This is the example of the positive linear relationship, negative linear relationship, uncorrelated relationship, and nonlinear correlationship. Okay, positive linear relationship of score where low or high scores on one variable relate to low or high scores on a second variable. In our example, low scores on depression are associated with low scores on number of hours using the internet per week. That is the table A, positive linear. And the negative linear relationship, where the low scores on one variable relate to high scores on the other variable. Low scores on depression, for the example, might be associated with high scores on use of the internet, suggesting a negative relationship. And next, about multiple variable analysis. Partial correlation used to determine the amount of variance that an intervening variable explains in both the independent and dependent variable. This is the example of partial correlation. Next, about multiple regression. Multiple regression is a statistical procedure for examining the combined relationship of multiple independent variables with a single dependent variables. And this is the example of multiple regression. Sorry. Okay, the last about multiple variable analysis is about meta-analysis. Meta-analysis is evaluating the result of individual studies and deriving an overall numeric index of the magnitude of result. The intent of this research is to summarize the result of many studies. Okay, next about the ethical issues in conducting correlation research. In data collection, ethics relate to adequate sample size, lack of control, and the inclusion of as many predictors as possible. In data analysis, researchers need a complete statement of finding to include effect size, and the use of appropriate statistics. Analysis cannot include making up data. in recording and presenting studies. The write-up should include statements about relationship rather than causation, a willingness to share data, and publishing in scholarly outlets. Okay, the last about this chapter is steps in conducting a correlational design. The first step is identify two variables that may be related. A correlational study is used when a need exists to study a problem requiring the identification of the direction and degree of association between two sets of scores. The second step is identify the individuals to study. For the example, the relationship between height of basketball players and number of baskets in a game. We might find a strong relationship among K-12 graders, but if we are selecting NBS player, these relationships may be significantly weaker. The third step is identify two or more measures for each individual in the study. We can obtain permissions from publishers or others to use the instrument. Typically, one variable is measured on each instrument, but a single instrument might contain both variables being correlated in the study. The fourth step is collect data and monitor potential threats. Two data scores are collected for each individual until we obtain scores from each person in the study. Next, we have to analyze the data and represent the result. The analysis begins with coding data and transferring it from the instruments into a computer file. Then the researcher needs to determine the appropriate statistic to use. And the last step in conducting a correlational design is interpret the result. This requires discussing the magnitude and the direction of the results in a correlational study, considering the impact of intervening variables in a partial correlation study, interpreting the regression weights of variables in a regression analysis, and developing a predictive equation for use in a prediction study. So that's all about the chapter 11, and I will continue the chapter 12 on the next video. Thank you.